Now it's time to do some analysis for our Dmap lab. We've done the reaction. I collected our white solid material. I calculated its mass so we can get a percent yield. So now we're going to look at the infrared spectrum of this. So here is the infrared spectrophotometer. And what you've got here is there's a laser in here that is actually bounced off this little window on top. And that window is actually made of diamond. And then it bounces back down and it's collected over here on this side. And it can be able to look at what vibrations in the infrared region occur. Much easier than we used to have to do these. You can do all the solid or a liquid on top here. You just want to make sure that it's nice and clean. We clean this with ethanol here. So we'll ethanol at that. I don't know who used this last. I don't know how clean they did it. Okay, so we'll go ahead and clean that off, make sure it's nice and dry. Now what this does is we have to think about this a little bit in that the air around us has molecules such as water and carbon dioxide that can absorb in the infrared region as well. And we don't want the instrument to look at that. So essentially, we need to set the blank, just like you did for visible. Here, we actually call it a background. So I'm going to tell it to collect a background sample. And so what it's doing is it's looking at anything that can be absorbed just from the air. And it's going to take 16 scans, and it's going to average those. All right, so we get for the first general one. It's not very pretty. But what's going to happen is the instrument's going to look at whatever absorptions are happening right now, and it's going to subtract those from our sample. So it's going to take that out. So we don't have to worry about the air or anything else, the carbon dioxide or the moisture from the air. I'm going to moisture peak here because we are in Georgia. All right, so we're not going to add that. So we've taken our background, and then we want to take our sample here, and it just takes a very tiny bit of the sample, and we can just put this right on the window there. So we just want to make sure that our window there's a little bit of white powder on the window there. Okay, so we move this into place. Now for a liquid, we could just take the measurement. For a solid, we want to push down and make sure there's good contact. So you just spin this until it starts to vibrate a little bit. Our sample's there. Okay, so now we're going to say collect a sample. We're going to call this Dmap and CH3I. And I'm the one taking this, so let's go ahead and put my name on it. Okay, so it says you name the file, then you're ready to prepare. We are ready. We say go. It's fairly quick. Again, it needs to do 16 scans. You do multiple scans for error correction and the like. Okay. Now it shows you what the spectrum looks like after 4 scans, but it'll take the rest of the 16 to give you better data. "14 scans and 16. Okay. And then we say, yes, we want to look at this and analyze the spectrum. Here is our spectrum. It has a nice thing where you can find peaks. You tell it what height you want it to look for and see how it labels the peaks for you there. Okay, so we'll go ahead and do that. Click replace. And there's our spectrum. Now yours may look slightly different because we have run this experiment several times, and so you will be provided with some data to analyze. The only other test we want to do is we want to do NMR. And so what we have here is an NMR tube. It just looks like a thin glass tube. It's made of a very, very special glass because when this goes into the instrument, it spins very, very fast. It's about $25 each for the tubes. And so we're going to use either the 400 or the 600 megahertz spectrometer for this. And what I just do is I just get a little bit of solid in this. It doesn't actually take that much. It's one of the advantages of NMR. Okay, so I just have a little bit of solid in the bottom. And then I'm going to add to it, in this case, D2O, deuterium oxide, as my solvent, because I need an aqueous solvent, but I want to make sure that it's not just water, because then the protons of the water would overwhelm the signal of the protons from my product. So we use the deuterium oxide because the deuterium is not NMR active.